Welcome back, everybody, for another episode of Taylor Tech Review. We've got huge AMD news today that we know you guys have been waiting for because AMD has finally pulled back the curtain on Zen 3 and they threw us a tease on their big Navi GPU. This episode is all about AMD. Let's get started. Now, if you haven't yet watched AMD's presentation, the link's in the description and I highly advise checking it out. And if you want Intel stock, you may want to hit pause real quick and go take an Advil before watching further. So first things first, let's do a recap of the information AMD gave us during the presentation. AMD's introducing Zen 3 as the Ryzen 5000 series. And if you're wondering, wait, what the heck happened to the 4000 series? Well, that chip is basically, for the most part, a laptop-only part. Since AMD introduced the Zen architecture back in 2017, the desktop and laptop chip names have kind of been out of sync with the versions of the CPU core. For example, the original Zen CPU in desktops was the 1000 series, but that same CPU in laptop was branded as the 2000 series. With Zen 3, AMD is fixing this and putting anything using the Zen 3 core under the 5000 series name. Finally, it's about time they straighten that mess out. They announced 4 new chips, which will all be available on November 5th, so no split releases this time like they did with Zen 2. Now, there were a lot of rumors before the presentation that the chips would be out in late October, but it's possible AMD wanted to make sure they didn't have a paper launch for this and wanted to make sure they had plenty of stock on hand. Now, AMD has kept the same naming conventions they used for Zen 2, so at the top we've got the R9 5950X with 16 cores, 4.9 gigahertz boost, and 3.4 gigahertz base clock with a 105 watt TDP for $799. Next up is the R9 5900X with 12 cores, a 4.8 gigahertz boost, and 3.7 gigahertz base clock, also with a 100 watt 5 TDP for $549. Followed by the R7 5800X with 8 cores, a 4.7 gigahertz boost, a 3.8 gigahertz base clock, again with a 105 watt TDP for $449. And last up is the R5 600 with 6 cores, a 4.6 gigahertz boost, and 3.7 gigahertz base clock with a 65 watt TDP for $299. Now, compared to Zen 2, there's only a small increase in the boost clocks, in most cases by about 200 megahertz, and in some cases the base clocks drop by about 100 megahertz. They came so close to that magical 5 gigahertz on the 5950X. Now, compared to the previous Gen 3000 series, this is a $50 price increase across the board, which doesn't seem too excessive for the performance we're getting, but do note that AMD is no longer including the heatsink and fan except on the R5 5600, so be sure to take that into account when you're looking at your build budget. What I found interesting, though, is that AMD is using the exact same 7 nanometer process that was used on Zen 2, not 7 nanometer EUV or even the enhanced 7 nanometer. This means that all the performance gains on Zen 3 we'll be talking about are purely from an architectural design. Now, later on in the video, I've got some speculations about a possible mid-2021 refresh option this leaves AMD, so keep watching to get that info. AMD is claiming that Zen 3 is an all-new design because they've done away with the old CCX design. See, in Zen 2 there were 2 4-core CCXs, and each CCX had its own 16 megabytes of L3 cache. If one of the cores on a CCX needed something from a core on the same CCX, it could go grab it directly from that shared 16 meg L3 cache. But if a core needed something from a core that was on a different CCX, it had to go talk to the other CCX, and this incurred a latency penalty. Now, with Zen 3, they threw out that old CCX design, and now all 8 cores are on the same CCX. But instead of 2 separate 16 meg L3 caches, there's now a single huge 32 megabyte L3 cache that's shared by all 8 cores. AMD is claiming a 19% IPC boost from Zen 2 to Zen 3. Now, IPC stands for instructions per clock, and it's basically a measurement of how much work a CPU can do each clock cycle. For example, this is totally made up. Say Zen 2 could do 1 million instructions per clock. Well, Zen 3 can do almost 1.2 million at the exact same clock speed. IPC doesn't create headlines like high clock speeds do, but it's incredibly important to how much work your processor can do at one time. AMD's given us a slide of how they got that 19% IPC boost, and as you can see, it wasn't, a single change, but a lot of smaller things that added up to 19%. Basically, it was like Tesla's battery day. Lots of small improvements that when you put them together make one heck of a difference. AMD are claiming a 40% improvement per watt compared to Zen 2, and a 2.4 times performance per watt compared to the original Zen chip. They also claim Zen 3 is 2.8 times more efficient than a Core i9-10900K, and that is honestly totally believable when you look at the power draw from a 10900K. Now, just so you guys know, AMD and Intel measure their TDPs very, very differently. AMD measures TDP by the max boost clock, whereas Intel measures TDP by the base clock. So when Intel says, oh, hey, the 10900K has a 125 watt TDP, that's absolutely true for when it's running at 3.7 gigahertz base clock. But when it boosts to like 5.3, that jumps to like 220 to 250 watts. Whereas when AMD says the 5950X has a 105 watt TDP, that's at 4.9 gigahertz. Now, it wasn't stated during the presentation, but Hardware Unboxed and I believe Gamers Nexus both reached out to AMD about that I/O chiplet, and AMD confirmed that it's the exact same 12 nanometer Global Foundries I/O chiplet that was on Zen 2, and they're even using the same Zen 2 package. This means that memory clock speeds haven't changed at all, so any memory that worked for Zen 2 will work just fine for Zen 3, and there's no change to the PCIe 4.0 lanes. Now, Zen 3 will already work on any 500 series motherboard, X570, B550, that is running the AGESA version 1.0.8.0. And for the best performance, an update to 1.1.0.0 will be available by November 5th. Motherboards with 1.0.8.0 started shipping around September, so hopefully most of the boards for sale by November 5th, when this thing goes on sale, will already have a fully compatible BIOS and be a lot less headaches. Now, beta support for the 400 series chipsets like X470 and B450 begins in January, so you've got a little wait for that. Now, AMD spent most of the presentation talking about gaming performance, where those latency improvements in Zen 3 really get to show off. They expect to take the performance gaming crown away from Intel with this generation, which means they'll have the best performance in gaming and productivity. Now, as always, you'll want to wait for independent reviewers to get their hands on a product before you take any of these numbers as fact. That said, I really do expect that these numbers are fairly accurate. Now, AMD showed a 5900X running Cinebench single core with a score of 631, making it the first desktop CPU to break 600 points. They then compared the 5900X to a 3900X in 10 games running at 1080p on a 2080 Ti. I guess AMD couldn't get a 3080 either to test with, where it was between 5 to 50% faster in games for an average of 26% faster. They then compared the 5900X to a 10900K, and it won in all but one game, Battlefield 5, where it lost by just 3%. On average, the 5900X is about 5% faster than the 10900K, which may not seem like much until you compare where that 3900X was against a 10900K. Now, in content creation apps, the 5900X again shows impressive improvements, especially in like SolidWorks CAD, where the 5950X was 27% faster than a 3950X, which was enough for it to take the lead against the 10900K by 6%. So AMD's basically sweeping the board with the best gaming performance, the best productivity performance, and doing it all using a heck of a lot less power than Intel. Now, last but definitely not least, literally during the last minute of the presentation, Lisa Su gave us a tease of Big Navi's performance. We see 3 games, Borderlands 3, Call of Duty Modern Warfare, and Gears of War 5, all running at over 60 frames per second at 4K, and just doing some quick Googling, that seems to be roughly, 90-95% of the performance of a 3080. Now, we don't know if this is the fastest Big Navi GPU coming, but we do know it was benchmarked on a 5900X, which is going to throw off comparisons on the 3080 reviews already out there a little bit. But the games were tested at 4K, so they're going to be mostly GPU limited. We'll find out more info on the 28th when AMD does the Big Navi reveal. This last bit is really more of a side note, but AMD has hit 25% market share on Steam's hardware survey. So it shows you the inroads AMD's been making on the market. Okay, now it's time for some of my own speculation. I mentioned earlier that 19% performance gains are almost purely architectural because AMD chose to use the exact same 7 nanometer process that was used on Zen 2. Now, a few episodes ago, I went over all the manufacturing process improvements that TSMC has available. Well, at this point, TSMC has three versions of the 7 nanometer process. There's N7, which Zen 2 and Zen 3 are made on, but there's also N7P and N7 Plus, both of which are fully design compatible with the original N7. So what this means is that if AMD wanted to, they could just go to TSMC and make a Zen 3 variant on N7P with absolutely zero changes to the design required, and they'll get a 7% performance boost, just changing the manufacturing process. Or they could make it on N7 Plus and get a 10% performance improvement. Now, if you combine this with my AMD roadmap leak in the same video, you'll see that on the leaked version of AMD's roadmap is a chip codenamed Warhol that's set to use the upcoming AM5 socket and PCIe 4.0 with a release date sometime in 2021. So, my speculation is that sometime in the middle of 2021, we're going to see probably an XT branded refresh of Zen 3, but it'll be on the new AM5 socket and possibly using that rumored X670 chipset to compete with Intel's Rocket Lake CPU. Now, since Warhol is still supposed to use DDR4 and PCIe 4.0, AMD can probably still use the same I/O chiplet from Zen 2 and Zen 3. This is where we are really starting to see the advantages that chiplets give to AMD when it comes to the speed of design. For Zen 3, AMD just had to redesign the CPU chiplet. They didn't have to touch the I/O chiplet, and that saved time and manpower, which is really important when going up against Intel, who's literally 10 times the size of AMD. And then when AMD is ready to support DDR5 or PCIe 5.0, they just have to redesign the I/O chiplet, and they don't have to touch the CPU chiplet. Now, you might be wondering why AMD would even do a Zen 3 XT refresh in the middle of 2021 when all those presentation slides keep showing Zen 4 coming at the end of 2021. That's because, according to their last quarterly earnings report slides, it only shows Zen 4 on the server at the end of 2021, but not on the desktop or the client, as the slides call it. So that Zen 3 XT refresh might have to keep them going until maybe February or March of 2022. And speaking of chiplets, AMD is apparently in talks to buy FPGA maker Xilinx, I'm assuming I'm pronouncing that right, for around $30 billion. Now, something like this is primarily for the server and data center market, but it would let AMD create chiplets using Xilinx's technology to add on to EPYC CPUs. I mean, we already know from AMD's supercomputer contract wins that they're going to be creating CDNA-based GPU chiplets to integrate onto their EPYC CPUs. So instead of 8 CPU chiplets, they can mix and match, say 4 CPU chiplets and 4 AI chiplets, or maybe 4 CPU chiplets, 2 GPUs, and 2 AI chiplets, or whatever combination a customer needs. Buying Xilinx would let them make a much wider variety of custom EPYC CPUs for different markets, like AI, compute, machine learning, and it would give AMD a huge boost on the software side, where they're currently really lacking the most. If the deal goes through, this is going to make AMD even more formidable on the server front. And that's going to wrap it up for today's episode. Thank you so much for watching, and if you like this video, hey, I'd really appreciate it if you would at least hit that like button, because YouTube's algorithm really does base its recommendation on likes and subscribers. So until next time, guys, take care. See you then.